Hello again, third block. Here are notes for Tuesday. Make sure that you've handed in the problems of the week that are due today and that you got a new copy of the problems of the week due next Tuesday. I'll be here again tonight from 7 to 8. So if you have any questions, come on by. If the doors are locked, give me a call and I will come down and let you in. Let's do the homework quiz for today. This will be the homework quiz for section 6.5. Pause the video and take about 5 minutes to answer this question. Let's go over the answer to this question. Your equation should be y equals either plus or minus 7 times the cosine of 2/3 x minus 2 pi over 3 minus 7. The way that you would get that answer is, remember, the period equals 2 pi over b. So in this case, 3 pi equals 2 pi over b. Multiply both sides by b, and then divide by 3 pi. That's how I got a b value of 2/3. For this last number, that has to do with the phase shift. I usually take what's inside the parentheses, set it equal to 0, and solve for x. When you solve for x, you get the phase shift. So if I plug the phase shift in for x right now, that will let me solve for c, and I get that c equals negative 2 pi over 3. Notes for today. Homework questions first about section 6.5. Take a minute, use the blue solutions manual or the blue answer key to go over any questions that you have about last night's homework. If that's not enough to answer your questions from last night's homework, make sure you stop by tonight at 7 o'clock. Now, notes for today. There was one thing in section 6.5 that we didn't do yesterday, I forgot, and so I want to go over it today. How to write the equation given a graph. Pause the video and take a moment to copy down this graph, and then we're going to write a sine and a cosine equation that would match this graph. This is basically the same type of question as when we are given the information about the graph and have to write the equation. We just need to take the graph and figure out what the information is. For example, what's the amplitude, the period, the vertical shift, and the phase shift on this graph. Whether it's a sine equation or a cosine equation, the amplitude is still the distance from the middle up to the top, or from the middle down to the bottom. And in either case, the amplitude is 2. Oops. The period of this graph, how long it takes to complete one entire cycle, is 4 pi. The vertical shift has to do with the midline. This graph has been shifted down 1, so it has a vertical shift of -1. The phase shift is going to depend on whether it's a sine or a cosine equation. Let's first take a look at this graph. This graph starts at 0. Which usually starts at 0, sine or cosine? Sine usually starts at 0. So if we're writing an equation for a sine function, the phase shift would be 0. We'll talk about what the phase shift will be for the cosine graph in a minute. But let's start by using this information and writing the sine equation. It would be y equals. Now usually we say plus or minus 2, but in this case only one of those answers would be correct. In this case the graph is going down from the beginning, so only -2 is correct. Inside the parentheses, we'll come back to that in a minute. The vertical shift is -1, so that goes on the outside. For the value being multiplied by x, we're going to use the equation that period equals 2 pi over b. So in this case, 4 pi equals 2 pi over b. Solve for b to get that b equals 1/2. So our sine equation is y equals -2 times the sine of x over 2 minus 1. That equation had no phase shift, so there wasn't adding or subtracting inside the parentheses. Now we need to go through and write a cosine equation. For the cosine graph, it still has the exact same amplitude, period, and vertical shift. So those parts of the equation are going to be the same. Y equals negative 2 cosine of x over 2 and minus 1 on the outside. But cosine graphs don't usually start at 0. They usually start at either the top or the bottom. And if we're using a negative 2, it means it would start here at the bottom. So what's the phase shift if this is a cosine graph? Instead of starting at 0, this graph starts at pi. So the phase shift is pi for the cosine graph. That does not mean we're just going to write plus pi right here in the parentheses. Remember, for the phase shift, we take what's in the parentheses, set it equal to 0, and solve for x. When we solve for x, the value we get for x is the phase shift. So let's plug the phase shift in for x and solve for c. So the cosine equation for this graph is y equals negative 2 times the cosine of x over 2 minus pi over 2, and outside the parentheses, minus 1. Is that the only correct answer? No, there are other correct answers for that. For example, we could have said positive 2 out front, and then we would have been looking way over here at 3 pi. So if we were going to use a positive 2 out front, we would need to have the phase shift be 3 pi. And then we could go through and get a completely different answer for C. So there's more than one right way to do it. I just showed one correct solution. The new notes for today start in section 6.6 with story problems. There are no new concepts. We're just taking story problems and applying it to what we've already done. The first example we're going to do is example 2 on page 389. Take a minute, pull out your book so that you can read the question in front of you. I wouldn't write the entire problem down in my notes if I were you, but we will pause the video quickly and give you a chance to write down the main points. The main points that I would write down are: a seated adult breathes in and out every 4 seconds. The average minimum is 0.08 liters. The average maximum is 0.82. And suppose you have a minimum amount of air at time equals 0. Take a minute to write down those important parts. We're supposed to write a function that models this situation, so we need to figure out what the information they're telling us means. A seated adult breathes in and out every 4 seconds. Is that going to be the amplitude, period, vertical shift, or phase shift? That's going to represent the period. So the period of this graph is 4. Average minimum is 0.08 and average maximum is 0.82. I'm going to take a minute and mark those on a graph. We're going to need to graph the function eventually, so let's just get a head start. So those two numbers aren't exactly the amplitude, but they're going to help us figure out the amplitude and help us figure out the vertical shift. The vertical shift has to do with the midline. So we need to figure out exactly what number is halfway in between those two numbers. There are a couple ways to do it. One way is add the two numbers together and divide by 2, or average them. If you do that, you get, let's see, add them together, we get 0.9. Divide by 2, we get 0.45. So 0.45 is the midline. Another way to get the midline would be to subtract the maximum, or subtract the minimum from the maximum. Take whatever you get, divide that in 2, and then add it on to the minimum or subtract it from the top. So for example, you take 0.82 minus 0.08. Take that number, cut it in half, and add that on to the bottom. Then you'd still get your 0.45. I think it's a little bit easier just to average them. Add them together, divide by 2. So this midline is actually our vertical shift. We have a graph that has a vertical shift of 0.45. What's the amplitude? The amplitude is the distance from the middle to the top or from the middle to the bottom. So subtract 0.82 minus 0.45. The amplitude of this graph is 0.37. We already said the period of the graph was 4 seconds. So if I'm graphing it, I can mark the period on my x-axis, cut it in half, cut it in half again, and count to get the last spot. The other thing they tell us is there's a minimum amount of air at time equals 0. So at 0, we're starting down here at the bottom, and then it's going to cycle through. So it's going to go middle, top, middle, bottom again. They don't specify in the question whether we're supposed to use a sine or a cosine equation. Does this graph look more like a sine graph or a cosine graph? It looks more like a cosine graph because cosine graphs either start at the bottom or at the top. You could use a sine equation, but if you use a sine equation, you're going to have to use a phase shift of 1 in this case. But if we use a cosine graph, we don't have to deal with a phase shift. So that's what we're going to do. We have all of the information we need to write our equation. Our equation is going to be y equals, the amplitude is 0.37. But in this case, since we're starting at the bottom of the graph, we need to use a negative 0.37 times the cosine of. We'll come back and use the period to figure out what's going on inside the parentheses in a minute. But outside the parentheses, we are going to add 0.45 from the vertical shift. To fill in the inside of the parentheses, we have the equation period equals 2 pi over b. So 4 equals 2 pi over b. Solve that equation for b. And it's going to have pi in it. This time there aren't pi's that are canceling out. We get 2 pi over 4, or in lowest terms, just pi over 2. So the value being multiplied by x is pi over 2. This is an equation that would model the situation. Y equals negative 0.37 times the cosine of pi over 2x plus 0.45. That's part A in the example. We graphed the function, that's part B. Part C, determine the amount of air in the lungs at 5.5 seconds. 5.5 seconds is an x value, so we're going to plug that in for x and figure out what we get for y. Y would be the amount of air in the lungs. So for part C, on your calculator, type in negative 0.37 times the cosine of pi over 2 times 5.5 plus 0.45. Before you hit equals, remember we said anytime you hit the sine or cosine button on your calculator, you need to be careful of what mode you are in. In this case, should we be in degree mode or radian mode, or does it matter? It does matter in this case. And in this case, we need to be in radian mode. The reason is when we were talking about the period of this graph, we said the normal period was 2 pi. That's radians. So that means this equation is radians. If, back here in the beginning, we set the period equal to 360 over b, then we would have an equation that would work in degrees. But our equation works in radians. So make sure you're in radian mode, then hit equals. The answer that we should get is about 0.71 liters. So at 5.5 seconds, there are approximately 0.71 liters of air in the lungs. The next example that we're going to do in this section is number 6 on page 391. So turn the page over to 391 and take a look at number 6. You don't need to write down all of those values on the table in your notes. If you would like to, go ahead. But I would just recommend writing down that this is number 6 on page 391, and then you can refer back to that table whenever you need to. All right, part A of this question. Find the amplitude of the sinusoidal function that models the monthly temperature. A sinusoidal function is a function that's either a sine function or a cosine function. Sinusoidal is just an adjective to describe this general shape. The amplitude. Amplitude would be the distance from the middle to the top or from the middle to the bottom. So what we need to do is figure out the middle. To figure out the middle, we're going to look for the maximum, look for the minimum, and we want to average those out. That'll be the middle. So the middle of this graph is at about 53.5. Is the amplitude 53.5? No, the middle is 53.5. So actually part B, what's the vertical shift? The vertical shift, or the midline, is at 53.5. The amplitude is the distance from that middle up to the top, or from the middle down to the bottom. So the amplitude is actually going to be 12.5. Part C says, what's the period of this graph? Well, how long does it take for this graph to repeat? It takes 12 months for this graph to repeat. Every year, these temperatures are repeating. Now that we have that information, part D asks us to write a sinusoidal function that models the monthly temperatures, using t equals 1 to represent January. That t equals 1 representing January, that's telling us about the phase shift. And I'll show you how to use that in a minute. Let's start with figuring out if we want to use sine or cosine. We can use either one. Just because it says sinusoidal doesn't mean we need to use sine. This graph looks like it starts with its lowest point. So if it's starting at its lowest point, is that more like a sine graph or a cosine graph? Like the last example, that's more like a cosine graph. Cosine graphs start at either the top or the bottom. And if it's starting at the bottom, that's going to be a negative cosine graph. So y equals negative 12.5 times the cosine of, leave a little space, vertical shift plus 53.5. Going back to use the period, the equation is period equals 2 pi over b. So 12 equals 2 pi over b. B equals pi over 6. So pi over 6 is the value being multiplied by x. We said we were going to use the t=1 representing January to help us with the phase shift. For right now, I'm going to fill in a plus C. We need to figure out what value C would be to make t=1 represent January. Now, by the way, since it says t=1, I really should be using a t here for time instead of an x. If t=1 is going to represent January, that means when I put 1 in for t, I should get 41 for my y value, because that's what the temperature is in January. So I'm going to plug that into my graph. I'm going to put 1 in for t and 41 in for y. And I'm going to try to figure out what value c should be. 41 equals negative 12.5 times the cosine of pi over 6 times 1 plus c plus 53.5. We are going to solve this equation for c and we'll be done. Let's start by subtracting 53.5 from both sides. Then we'll divide by negative 12.5. We need to take the inverse cosine on both sides to get rid of the cosine. Inverse cosine of 1. Let's think about the unit circle. The cosine value is the first value. So when we do inverse cosine of 1, the angle that we're talking about is 0 degrees. So by subtracting pi over 6 from both sides, the c value that we need in this equation is negative pi over 6. So we'll go back, recopy the equation with a negative pi over 6 in for c. Our answer is y equals negative 12.5 times the cosine of pi over 6 times x minus pi over 6 plus 53.5. The next part says use your equation to estimate the average monthly temperature in February. Well, if t=1 represented January, what would February be? February would be 2. So to answer that question, we're going to put 2 in for t and see what value we get out for y. On your calculator, type in negative 12.5 times the cosine of pi over 6 times 2 minus pi over 6 plus 53.5 and see what you get out. You are using the cosine key, so be careful of what mode you're in. Just like in the last example, since we use the period equals 2 pi over b, we do need to be in radian mode. When you do that, you should get 42.608 degrees for February. It's a pretty good estimate. Back in the problem, the actual average for February was 44, so we're off by 2 degrees. For part F in this question, they want you to do the same thing for October. So for October, we're going to let t equal 10. Plug 10 into the equation for t, type it in on your calculator, and see what you get. When you plug 10 in, you should get 53 degrees. So that's an even better estimate. It's only off by 1 degree from the actual value. Your homework in this section is very short. It's on page 391, problems 8 through 13. Take about 30 minutes now to start working on that assignment.